Okay, so I just want to start out by essentially capturing what this question is asking, which is what is the resultant speed of the aircraft? That should immediately tell you that it's not asking for a vector, it's asking for the magnitude of the vector. So we don't care about direction at the end of the day. But to get to the speed, we need to account for the direction of both vectors. So we will just say, first of all, the airliner is flying 300 miles an hour due east. So that is a vector in the x direction, correct? Because east is over here. Okay, and we'll call x hat, and the little hat on top of the x just denotes that's in that direction. So we will call this v, and we will say up here that v is equal to v is going to be equal to 300 miles an hour, obviously, but we'll exclude the units since they're all the same units. And then we have w over here, and we'll just call this vector w for the wind speed, and this is going to be 100. Okay, I apologize, I don't have a mouse on me right now. I will get one in the future. So essentially, I just want to start out by saying the jet enters a region where it is encountering a wind that's 100 miles an hour. So we will call, in physics, we like to represent the particles, the objects as point particles just to make life easier. So if we represent the plane as a point particle right here, and it enters the region, the wind is blowing this way on it, and also its own engines are providing a velocity this way. So we're essentially combining both of these vectors into some new resulting vector. I apologize for the nonlinearity there. Let's try to see if we can just get a straight line. So the resulting vector is going to be coming out of here, and it's going to be over here somewhere. Okay? So we can just call this V final or something like that. But first of all, it's saying that the wind is blowing 30 degrees north of east. So here's east in the x direction. North of east is 30 degrees upwards. So our angle is right here. This is going to be 30. Okay. Now, if the magnitude of W is 100 and this is 30 degrees, we can break W down into its x and y components. So we're just going to go over here real quick, and I'm just going to show you breaking W down into its x and y components. So essentially we have, here's the x component and the y component of W, okay? And then this is 30. And then we have 100 over here. All right, so it basically, we know SOHCAHTOA, so we can go 100. We can just say cosine of 30 is going to be able to give us our adjacent side. And basically SOHCAHTOA, right? So ka means adjacent over hypotenuse. So we have adjacent over hypotenuse. And the hypotenuse is 100. So the adjacent side is going to be, it's going to be 100 cosine 30. And oh my goodness, I'm going to buy a mouse today. I really apologize for this. But essentially, 100 cosine 30 is going to come out to 86 point. It's going to be like 86.6. And one way you can see cosines or sines of something, and this is going to be the adjacent side. One thing you can see cosines and sines as, you can say cosine 30 is going to be a percentage. Whenever you have the cosine or sine of anything or tangent, it's always going to be between -1 and 1. So you can basically say this is cosine 30 is some percent of 100. Okay? So you're basically saying, okay, well, 86.6 is some percent of 100. That's really what cosine 30 is. And essentially, sorry, I looked at the recording button. So essentially what we're doing here is we're going to be getting our next part, which is the opposite side. And to get the opposite side, you're going to go, of course, 100 sine 30. 100 sine 30. And this is going to equal 15. Because the sine of 30 is 1/2. Or sorry, 50. Okay. Now, can you finish from here? So essentially what we have is we have the x and y components of W. We have the x and y components of V. So this is really, so if we since we're breaking this down, we're essentially taking, this is going to be 86.6 in the x hat direction. Okay, and I'm just writing these out. So this is 300 in the x hat direction plus the plane's velocity vector is going 300 in the x hat and 0 in the y hat. Remember, the hat is just the direction. Okay, and let me just highlight that point there. And then this is 50 in the y hat, because remember, we're going 50 in the y direction. The wind is making it go 50 miles an hour in the y and 86.6 miles an hour in the x. So you essentially have these two vectors, and what you can do is you can add these two vectors to their components. And essentially what you'll get is you'll get, 386.6 in the x hat direction. And I'm going to get a mouse after this. I really apologize. This is my first rodeo with this whiteboard without a mouse. So essentially what we're doing here is we're getting these components, and then to take the magnitude of that, use the distance formula, which is basically the square root of this squared plus this squared is going to be your answer, and you should get, my final answer came out to, let's see here, sorry. So I'm getting 389.82 miles per hour. As the speed. And again, it's asking only for the resultant speed. It's not asking for the direction. So this is what you should come up with, and I'll leave it up to you to fill in the gaps. And good luck. Good luck to you.